Hello, thank you all for attending the 30th Annual Science Research Conference with the Federation of American Societies for Experimental Biology. It is wonderful to see you all again. Today, we have over 4,000 established scientists and experts who are sharing their work through lecture, poster sessions, and informal discussions. My name is Isaiah Ozuna, and I conduct research at the National Institute of Health as the lead bacterial research scientist. I attained my Master's of Science from the University of Arkansas for Medical Sciences, where I also received my Master's of Public Health, concentrating in epidemiology. I have been conducting epidemiological research for 7 years now on the topic of antibiotic overuse. Today, we will be discussing the history, production, risks, and financial strain that this issue has gained over the years, as well as the rising theories. First, to understand antibiotics, we must understand how bacteria affects the body. Now, I know we veterans have a clear understanding of this, but there are several interns and first year students here whom I'd like to address as well. So bear with me. Webster describes a microbe as a microorganism that can cause disease or fermentation. These microbes completely cover our body inside and out, meaning there are tens of trillions of microorganisms inhabiting our body. Some of these microbes defend our body and help break down food. There are 5 types of microbes that we live with, but today we will be talking about bacteria. Bacteria are single-celled organisms that can replicate themselves through binary fission. The replication process produces identical bacteria, and those replicated microbes have the potential to mature quickly under the right exposure. This allows bacteria to survive environmental changes. As a cloth merchant, Anton van Leeuwenhoek discovered these microbes accidentally by magnifying his glasses in the late 1670s. He grinded his glasses so that he could analyze the weave of the cloth more precisely, and in that process, he was able to capture magnifications 500 times life size. Centuries later, antibiotics were discovered. Alexander Fleming's discovery of penicillin in 1928 was a spark that lit the eternal flame of medicine that has illuminated our progress today. Centuries before us, something as small as a cut could equate a death sentence, but the discovery of penicillin, the first antibiotic founded, gave hope to those exposed to diseases such as pneumonia, gonorrhea, and fever. Although the finding of this antibiotic was accidental, it has been instrumental. It has been an intermediate factor on the causal pathway to advanced medicine. Currently, 50% of the world's largest pharmaceutical companies are housed in the United States. Pfizer, the leading pharmaceutical company, produces medicines and vaccines for humans and animals, and in 2014 had a worth of $203.93 billion. In the same year, 266.1 million courses of antibiotics were dispensed to pharmacies across the United States. In 1945, shortly after the discovery of penicillin, Alexander Fleming, the modern founder of antibiotics, stated, "The public will demand the drug. Then will begin era of abuses." Over the years, antibiotics have treated people from bacteria infections. However, a controversial topic arose on the subject of antibiotic overuse and resistant bacteria strains. Let me explain. As stated earlier, when bacteria or microbes multiply, they replicate in a way that can be conducive to their environment. This means that if a microbe comes in contact and adapts to the medication intended to destroy it, then it multiplies. It has just started a strain of bacterium that is resistant to that antibiotic. However, this is just one way that antibiotic-resistant bacterium come about. Ventola, a scientist who has studied this phenomenon, stated, that microbes do not have to replicate to pass on resistance, but due to horizontal gene transfer, otherwise known as HGT, antibiotic resistance can be passed on to different strains of bacteria. Problems arise within the healthcare community because major pharmaceutical companies and hospitals spend billions of dollars a year for the production and disbursement of this product, and it does not produce the desired effect it was intended for. Instead, we are exposed to overuse, resistance, and possible health risks. One study suggests that 30 to 50% of whom are prescribed antibiotics are done so inappropriately by choosing the wrong type of antibiotic, an incorrect dosage of, or course, thus steadily promoting strains of bacteria resistance. On this slide, I would like to highlight some statistical data for overprescription for antibiotics in the nation. I stated earlier in my lecture that the United States is responsible for prescribing around 200 million prescriptions a year. This means that 60 million to 100 million of these prescriptions in our nation are inaccurately prescribed, filled, and possibly consumed. No wonder we have a problem. According to the Center for Disease Control, in 2014, 266.1 million of courses of antibiotics were provided to clinics across the United States. I stated this alarming statistic in previous slides because that also means for every 6 people in the United States, there are 5 prescriptions written for each one every year. Azithromycin and amoxicillin being the most common prescribed antibiotics. In 2014, the state of Arkansas prescribed 1,021 to 1,285 courses of antibiotics per 1,000 individuals, awarding us one of the highest unnecessary prescription rates in the nation. This is an overwhelming risk of exposure that almost all Americans are exposed to. Essentially, we are contributing to the strengthening of antibiotic. We have all fell victim to the thought of forgetting to take our prescribed antibiotic after a few days of being on them. We start to feel better. We look to brighter days while our prescribed pills fall to the back of our medicine cabinet. Even if you haven't, you know someone who has. The World Health Organization, or WHO, describes another way that we are carelessly enhancing these antibiotic resistant superbugs. They state that the inability to complete your prescribed dosage of antibiotics could put your body at risk for further exposure to drug resistant bacteria. Let me paint a picture for you. You stop taking your antibiotics in the middle of your course because you start to feel better. You now have welcomed a risk because you did not finish your dosage as prescribed. Since you did not complete your prescribed dosage, the treatment doesn't exterminate all of the bacteria which it is targeting. Instead, the bacteria is exposed to the drug. It doesn't die, but it mutates. It continues to replicate or pass on the developed mutation and will then foster a new strain of bacteria that is resistant to the prescribed antibiotic. This process ensures resistance to the prescribed antibiotic, and that prescription will no longer be effective against that mutated bacteria strain, or the developing term for it, a superbug. From this standpoint, we put our friends, family, and even strangers at risk of exposure to these resistant strains of bacteria and possibly wasting their time and money to even get a prescription filled. Because antibiotics have been used for the past 70 years or so, it is no wonder why many people only theorize about the possibility of antibiotic resistance. In 2013, the Center for Disease Control published 3 urgent threats or drug resistant diseases that are prominent in the United States. An example of this is gonorrhea, a sexual transmitted disease normally treated with antibiotics. In 2013, there were 246,000 drug resistant gonorrhea infections out of a total 820,000 regular diagnoses. This means that there is a 30% prevalence of drug resistant gonorrhea infections per year. For years, They talk about we have been having today about superbugs and antibiotic overuse have been theorized, but in 2017, that theory became a reality. In September 2016, a 70-year-old woman died in Nevada from antibiotic resistance by way of pneumonia. This superbug is coined pan resistant due to its ability to not be affected by any antibiotic offered in the United States. That particular strain of infection is resistant to all 26 treatments that the U.S. has to offer. The CDC estimates that 23,000 people die every year from multi drug resistant infections. Although this isn't the first time someone has died at the hands of a drug resistant bacteria, the unfamiliarity of it has turned many heads. Scientists have discovered genes within the bacteria of the superbugs in certain diseases that are giving them their resistance to antibiotics. Researchers in Denmark and the West Indies report that shutting off the genes with the aid of helper drugs, which increases the antibiotic potency, could completely restore the bacteria's susceptibility to medications that were once resistant. This means that the tens of thousands of microbes out there who are resistant could become vulnerable to antibiotics again. Certain diseases with exposure to the helper drugs provided could reverse the antibiotic resistance and treat countless individuals. I will now open the floor for questions if there are any. Yes, go ahead.
Do you think that the woman in Nevada who died from the antibiotic resistant pneumonia could have benefited from the helper drugs that you spoke about in your last slide?
Hmm. Although this procedure is still being researched and tested, I believe she could have benefited from such a treatment. The scientists who are carrying out the research in the helper drugs discovered the ability to shut off the genes in the bacteria specific to what caused the woman in Nevada to die, Klebsiella pneumoniae. If this research is continued and validated, many more lives like hers could be saved. Thank you for your question. I would like to thank you all for attending my presentation on antibiotic overuse, the multi-billion-dollar crisis. I hope you all enjoy the rest of the conference celebrating the 30th Annual Science Research Conference here with the Federation of American Societies for Experimental Biology. Thank you.